Hi, and welcome to your logged test review. I'm just going to go over how to do all the problems, and you can watch as much of this as you need to. If you need to, fast forward to the questions you don't understand. If you want to watch the whole thing, go right ahead. Alright, for number 1, it says write in exponential form. I have log base 5 of 125 equals 3. So I need to determine what B, C, and N are, and I need to put this in Ben form. So my base is the little number, the subscript, which is 5. My exponent is what the log is equal to. Remember, the log is just an exponent. And my number is 125. I'm going to put this into Ben form. So my base is 5. My exponent is 3. My number is 125. You can always check this. This needs to be a true statement. It won't ever be a false statement when you're changing back and forth. For number 2, write in logarithmic form. Okay, again, identify what B, speed, and N are. So my base excuse me, is a number that's being raised to the power. So my base is 9. My exponent is the power, so it's just 3 halves. And my number is 27. We need to put this in log form or being form. It's log base B from N equals B, because remember, the log is equal to the exponent, and the base is always the little number here. So it's log base 9 of 27 equals 3 halves. Okay? Moving on. For number 3, if f of x equals the log base 4 of x, find f of 64. So what we need to do is substitute 64 in for x and then evaluate it. So we have log base 4 of 64, so putting 64 in place of x. I'm searching for what's missing. I need to evaluate this. If you need to, write out your B, E, and N. My base is 4. My exponent is what I'm looking for. My number is 64. So 4 to the what is 64. Or 4 to the third is 64. So 3 is what we're looking for. For number 4, I saw a lot of people making this mistake in class. A is not equal to 5. The log of 5 is equal to A. And the log of 3 is equal to B. So express in terms of A and B. So what I need to do is, when I have an exponent, use my properties and pull it out in front. So I have 2 log of 3 over 5. Well, whenever I have a division, I'm going to subtract my log. Remember, this 2 was around this whole thing, so that means I still need to keep my 2 and have parentheses. So log 3 minus log 5. Distribute my 2. So 2 log 3 minus 2 log 5. And now I can make my substitutions. Log of 5 is equal to A. The log of 3 is equal to B. So it is 2B minus 2A. For number 5, we have 2 options, and I'll show you both options. The first option is to turn this into exponential form. So B is 3, B is x, and N is 54. So we have the log, okay, turn it into exponential form. 3 to the x equals 54. There is no power that I know of that I can take 3 and raise it to and make it 54. So when you don't know how to do this, this is where you have to take the log of both sides. So log of 3 to the x equals the log of 54. Now take your x, put it out in front using our properties. So x log 3 equals log of 54. Divide by the log of 3 to get x alone. So x equals, I type it into the calculator, log 54, make sure I close my parentheses, divided by the log of 3, and I'll get 3.63. And I'll have you round to 2 decimal places or the nearest hundred unless I tell you otherwise. The other way to look at this problem is I have just an x and I have a log of a number in the base, and I can use my change of base formula. So if I do that, x would be equal to the log of the number over the log of the base. We briefly did this on day 3 with the common logs and the natural logs. Just type it into your calculator and you'll still get 3.63. For number 6, we need to solve this equation. Again, identify what b equaling nr and see if you can't get it into exponential form and do something with it. So my base is 25, my exponent is 1/4, and my number is x. So if I rewrite this, it's 25 to the 1/4 equals x. All I need to do is type in 25 to the 1/4 on the calculator. It would look like this. So we do 25 caret, parentheses 1 divided by 4, close parentheses. That's equal to x, and the nearest hundred is 2.24. Number 7, same idea. Turn it into exponential form first, so we have to identify what b, e, and n are. B is b, c is -2, and n is 16. So b to the -2 equals 16. Well, from the last chapter we know we can raise it to the reciprocal power. Cross off over here. So b is equal to 16 to the -1/2. So I have a negative exponent, flip it, and then make your exponent positive. 1/2 power is the square root, so b is equal to 1/4. Or type it into your calculator if you don't remember how to do it. 1 divided by 16, make sure your parentheses around 1/16. Caret, make sure your parentheses around your fraction. Okay. And then if you do that, you would get 0.25, which you could turn into a fraction. For number 8, express as a single logarithm. This is when I'm going to condense. 1/3 becomes an exponent. 4 becomes an exponent. 2 becomes an exponent. So I have log of a to the 1/3 power plus the log of b to the 4th power minus the log of c to the 2nd power. All my additions go in the numerator, all my subtractions go in the denominator. So this is log of a to the 1/3, c to the 4th, over c to the 2nd, and 1/3 is just a cube root. So cube root a, b to the 4th, c squared. Okay, that is it for page 1. Number 9, we're going to expand using the properties of log. So we're going to undo what we just did in the last problem, so we're going to go backwards. If I have a product, it becomes an addition. If I have a division, it becomes a subtraction. So it's the natural log of a to the 4th plus the natural log of b minus the natural log of c cubed. Now, my exponents have to go out in front. So it's 4 natural log of A plus the natural log of B minus 3 natural log of C. For number 10, we need to solve it. Well, I have a coefficient out here, so I have to put that up in the exponent. So I have the log of x squared equals the log of 49. Now remember, when I have two logs equal to each other, I can set the arguments equal to each other. So it's x squared equals 49. Take the square root of both sides. X equals plus or minus 7. Remember, we said we can't have negatives if there's just a log of x. So we just need x's equal to 7. And negative 7 would get rejected. For number 11, if I have an equation and I can't get the bases to be the same, like this, then I need to take the log of both sides. So it's log of 6 to the x equals the log of 144. Well, my exponent out in front, x log 6 equals the log of 144. The x alone, divided by the log of 6. So x equals, when I do that on the calculator, 2.77. For number 12, we are adding logs, which means I can multiply. So I have the log of 12x equals the log of 96. Two logs equal to each other, so I can set the arguments equal to each other. So 12x equals 96. Divide both sides by 12. So x equals 8. Alright, for number 13, we still have a log with an addition, which means I have to do the product. It's a log of x times x minus 3 equals the log of 18. Well, I need to distribute. So the log of x squared minus 3x equals the log of 18. I have two logs equal to each other, so set the arguments equal to each other. X squared minus 3x equals 18. Because I have x squared, get it equal to 0. X squared minus 3x minus 18 equals 0. And then I can factor this one. X and x, 6 and 3, minus 6 plus 3. So x equals 6 and x equals negative 3, which we have to reject. If x equals 6. Can't have a negative 3 here when you check. We did one very similar to 14 on the front page. You can use change the base formula, or you could put it into exponential and then take the log of both sides. And when you do that, you end up using the change the base formula. The change of base formula is simply x equals the log of 21 divided by the log of 4, because it's the log of the number divided by the log of the base. So x is equal to 2.0. Or you can go about the other way. The base is 4, my exponent is x, and the number is 21. I do not know of a number that I can use 4 to get 21. Therefore, you can take the log of both sides. So log of 4 to the x equals the log of 21. Bring the x out in front. That's what I've happened to log by the sphere. Divide both sides by the log log 4. As you can see, log 21 divided by log 4, that's what I end up with over here. So again, x is 3.30. For number 15, it is simply a calculator problem. Type it in just like you see it. Down to the nearest hundredth, just 2 decimal places, you get 0.64. For number 16, find 4 decimal places. The natural log of x equals 1.2498. This is where we need to use second log, and in this case, we have natural log. So it's second ln on the calculator of 1.2498. And when you type it in, it's actually going to look like e to the caret of 1.2498, which in this case is 3.4896. Alright, your favorite is next. Word problems. When Toby was born, his parents invested $1,500 in a fund that paid an annual interest of 4%. How old will Toby be when the investment is worth at least $5,000? And we're going to use A equals A sub 0 times 1 plus R2 to the 2, or 1 plus R to the 2 power. So A, remember, is our ending amount. And in this case, we want this to be equal to $5,000. A sub 0 is our starting amount, which is 200. R is 4%, so 0.04. And T is what we're looking for. So it's 5,000 equals 1,500 times 1 plus 0.04 to the T. I'll divide both sides by 1,500. And this is actually a fraction I can reduce it to. 10 over 3 equals 1.04 to the T. Now, go ahead and take the log of both sides. Remember, you can use log or natural log, it doesn't matter. You just can't change in the middle of the problem. 0.04 to the T. Bring the T out in front. And then we need to get T alone to divide by the log of 1.04. And those have to cancel each other out. So I will type this into the calculator as log, parentheses, 1 or 10 divided by 3, close to parentheses, divided by the log of 1.04. And when you do that, you get 30.70, I believe. Can't really see. It might be 7.720. 30.20 is equal to T, and at the very least, T has to be 30 grams. The reason why we do it this way is because we're not talking about Your parents' loans without anything else. And putting away money and paying your bills. Alright, let's try and rate things. Chance of saving money to go on a trip to Europe for the 25th wedding anniversary. They have 5 years to save $10,000 per trip. If the 5-year CD they buy now pays 4.5% interest compounded continuously, how much do they need to invest now in order to have $10,000 for the trip? Use A equals A sub 0 ECR2. Remember, E is just a number, A is your spending amount. In this case, is $10,000. That's a target. A sub 0 is how much do we have to invest. We don't really know. E is our number. R is the rate, so it's 0.045. And T is the time. And they've got how long? 5 years. So it's 10,000 equal A sub 0 is what we're looking for. E to the RT. R is 0.045 and T 5. So 10,000 equals A sub 0. And when we multiply the exponent, we will have E to the 2.2. No, 0.2. Divide by E. The A sub 0. And when I put that into the calculator, I would get $7,985.16. That's how much money they have to start. Number 19 is our final problem, and it's our graph. Some of this is exponential, should be pretty easy. Get the graph of y equals 3 to the x. Now remember what we did for x. We did our t-chart. And I said you only have to do -2, -1, 0, 1, and 2. And since my function is 3 to the x, this is 3 to the -2, which is 1/9. This is 3 to the -1, which is 1/3. 3 to the 0 is 1. 3 to the first is 3. And then finally, the squared is 9. So come over on the graph. This exponent with your fractions. There's 1/9, there's 1/3. There's 0, and there's 3. There's 9. And this is f of x equals 3 to the x. Part B says to find the graph of x inverse. Well, if we had this, y equals 3 to the x, find the inverse and switch x and y. So x equals 3 to the y. I can't leave it in that form, therefore I must put it into logarithmic form. Log base 3 of x equals y. And in this case, because we're using function notation, it will be x inverse of x. Part C says to graph the inverse. Well, remember we said we just switch x and y. So this becomes negative 2, negative 1, 0, 1, 2. And looking back on my chart, we have 1/9, 1/3, 1, 3, and 9. And we graph that and just estimate. And you don't actually cross the axis, you get really close to it. And we call it a day. So I label this as X inverse X equals log base 3 of X. So that was my equation. And part B asks for the equation of the line, which is F inverse of X is a reflection of F of X over what line? X line Y equals X. And if you remember when we first did this, I showed you that. And that is the line, right? Because that's when you look at the graph, you can see that if you fold it on that line, it is indeed a reflection. Alright, that is everything that's on the graph. I hope this was helpful for you. Happy studying, and I'll see you in class on Wednesday.